The word agent, we hear it all the time, right? A sports agent, a secret agent, heck, even a chemical agent. But what if I told you that this one little word is the thread that connects ancient Roman law to the most advanced AI we're building today? It's a huge concept, so let's dive in and really unpack what it means for something or someone to be an agent.
All right, here's the game plan. We're going to start with the OG agent, the one from the courtroom. Then we'll see how that idea got a massive digital upgrade. We'll peek inside the mind of an AI agent, see what happens when you let millions of them loose to build their own worlds, and wrap up with what this all means for our future.
So, part one, the original agent. Let's wind the clock way, way back. Before computers, before code, this whole idea of an agent was born from a really basic human need, in the world of business and law. So here's the classic legal definition. An agent is just someone who's authorized to act on behalf of someone else, the principal. Think about it. A real estate agent is working for you to buy a house. A sports agent is cutting a deal for an athlete. The agent's actions legally bind the principal. And that's the key phrase right there, acting on behalf of. Remember that because it's going to be super important.
Okay, but here's where it gets really cool. What happens when you take that idea, acting on behalf of someone, and you give it to a piece of software? What if your agent isn't a person anymore, but a program? And what if its principal isn't a human, but just a goal you want it to achieve?
Well, that exact question brings us to part two, the digital agent. This is where we take that old school legal idea and give it a serious 21st century upgrade. We're talking about translating acting on behalf of into pure code.
So what is an AI agent? Well, at its core, it's a program that can look at its environment, make its own decisions, and take action to hit a specific goal. Yeah, your smart home assistant, that's an agent. The chatbot that helps you with your order, that's an agent too. They aren't just blindly following a script, they're figuring out the best way to get the job done, all on their own. So what's their secret sauce? What makes them tick? Well, it boils down to a few key things. They're autonomous, they don't need you holding their hand. They are laser-focused, totally goal-driven. They're perceptive, constantly soaking up data. And they're adaptable, so they can switch up their game plan if things change. And the really wild part? They're getting collaborative, working together with other AIs. Okay, but how? How does a bunch of code actually think? To get that, we've got to pop the hood and take a look inside the agent's mind. It's actually not that different from how we think. You can break it down into 4 basic steps. First, it's got to perceive the world. That's profiling. Then, it needs to remember what it's learned, which is its memory. After that comes the brain of the operation, the planning part, where it weighs its options. And finally, it takes action and actually does something. So, perceive, remember, decide, and execute. Simple, right? And these agents have been evolving, getting smarter and smarter over time. It started with the really basic ones, simple reflex agents, which are just like, if this, then that. Then we got model-based agents, which could build a little mental map of their world. Then goal-based agents that could actually plan ahead. Then it got even fancier with utility-based agents that try to find the best or, happiest outcome. And now we're at the top of the food chain, learning agents that literally get better and better on their own. So, one agent is cool, but what happens when you have thousands or millions all interacting at the same time? Well, this is where things get absolutely wild. This is where agents start building worlds. Welcome to the world of agent-based modeling, or ABM for short. The big idea here isn't to create one genius AI. No, it's about creating an army of pretty simple agents. You give each one a few basic rules, and then you just sit back and watch what happens to the whole system. And this creates something truly mind-bending called emergence. It's one of the coolest ideas in science. It's when the whole system starts doing things that none of the individual parts were ever programmed to do. It's the classic idea that the whole is way, way more than the sum of its parts. I mean, think about it. You can give each agent a stupidly simple rule, like stay close to your buddies, or if the price is low, buy. And from those tiny individual actions, you get these huge, complex, and totally unpredictable patterns on a massive scale. It's incredible. And this idea has been around for a while. It goes all the way back to the 40s with von Neumann thinking about self-replicating machines. Then in the 70s, it just blew up with stuff like Conway's Game of Life, you've probably seen that one, and Thomas Schelling's famous model that showed how segregation patterns could appear even if no single agent was particularly biased. Just wow.
Okay, I know this all might sound a little bit abstract, like a science experiment, but it has massive real-world impacts. Which brings us to our last section, our agent-driven future. And trust me, this is the part where you see why all of this really matters. Take epidemiology, for example. Scientists use these models to simulate how a virus spreads. Each person becomes an agent, and you can test out different strategies, like lockdowns or vaccine rollouts, in a computer simulation before you have to make those tough calls in the real world.
Or how about finance? Economists build virtual stock markets with agent traders, but instead of making them all perfect rational robots, they give them different, messy, human-like behaviors. And suddenly, they can start to explain things like market crashes and crazy bubbles that the old models just couldn't handle.
And self-driving cars, this tech is everything. I mean, companies like Waymo, they can't just test their cars on real streets for every possible situation. Instead, they run billions of miles in simulated worlds filled with agent drivers, agent pedestrians, you name it. They test their AI against every crazy scenario imaginable, all to make the real roads safer for you and me.
And the list just goes on and on. It's used in healthcare to design custom treatment plans for patients. It's used in robotics to get swarms of robots to work together in a factory. This stuff is quietly rebuilding our world, piece by piece, from the ground up.
But look, with all this power comes some pretty big challenges. We've got to worry about bias, making sure these agents don't learn the wrong things and cause harm. The complexity is a double-edged sword. It can become totally unpredictable. And then there's the big one, accountability. When an agent messes up, who's responsible? And that brings us right back to where we began, full circle. Remember the legal agent? The principal was responsible for what the agent did. Simple. But now, when an autonomous AI, designed by one team, trained on data from 1 million sources, owned by some giant corporation, makes a mistake, who's the principal then? Who's on the hook? That is the massive question we have to figure out, and we have to figure it out fast.